Hello, good afternoon. My name is Brant Kasbaum, sales engineer here at ACI. Thanks for joining us this afternoon for a webinar on temperature sensors and some of the most frequently asked questions that we receive about our temperature sensor product line. A couple of quick notes. Please put any questions that you have that I may not answer or that aren't part of the presentation into the chat over on the right-hand side of the screen. And when I'm finished with the presentation, I will answer those questions right as soon as we're done with the presentation. I'm going to be coming at you kind of rapid fire with a lot of the questions today, but we've put all of these FAQs into a document and put it on our website, and that's at workaci.com/FAQ. So if there's something that you didn't hear my full answer, or if you have additional questions, a lot of those will be addressed in that document. So let's jump right into it. Today, temperature sensors, they're our oldest product line. They're our most common product line. And that may be what we here at ACI are most well known for. Also, one of the reasons why we wanted to talk about temperature sensors today, given the current supply chain situation, we wanted to talk about products that we have readily available. The vast majority of the parts and products that I'm going to talk about today are readily available. And as always, if you've got questions about specific product availability, lead times, or order status, please reach out to me or anybody here at ACI. Happy to help at any time. Apologize if you hear some background noise. There is some work being done here right close to where I'm recording today. And so you might hear a little scuffle here and there. And we are recording this webinar, so if you have to leave partway through or don't get to see or listen to the entire presentation, we will be archiving it on our YouTube channel. It'll be up there within the next day or two. So we're going to start by talking about a few general questions regarding temperature sensors or temperature sensing in general. And then we'll move into some specific configuration questions for duct and room and outside air and the like. So over the years, the most common question is, what do I need? Which type or which sensor do I need? And I think that comes from people looking at our data sheets and seeing dozens and dozens of options. And so when looking at which specific configuration you need, whether it's a duct mount, immersion, averaging, and the various lengths and options, the job requirements are going to determine that, whether you need a waterproof or weather-tight box or which probe length you need. And as far as which sensing element is required, the vast majority of that is a matter of system compatibility, not necessarily which sensor or sensing element is better or worse. Most PLCs and DDC systems have a standard or a default input, and we can help match up which sensor is going to ensure system compatibility with the control system that you're working with. Along those lines, the next frequent question we get is, what's the difference between RTDs, thermistors, and transmitters, and which one is best? So that's something that we'll hear pretty regularly is just give me the best one. And all of these have different advantages and disadvantages and strengths and weaknesses. So depending on the specifications of the job's requirements and system compatibility, one specific sensor or sensing element may be better or worse than others, but that's definitely something we here at ACI are happy to discuss with you. Don't want to take the time today to go into all of the different advantages and disadvantages of RTDs versus thermistors versus transmitters, but they all have trade-offs. There's no one sensor that is, the cheapest, the most accurate, the most reliable. They all have some trade-offs in the nature of how they measure temperature. More common question in recent years is which can be NIST certified. And just about every single one of our temperature sensors can be provided with an NIST certificate. There's only very limited exceptions. Primarily, those exceptions are based on the physical size of the sensor. For example, rigid averaging, if a probe is longer than 36 inches, it won't physically fit into our testing chamber. And then we also have some LCD wall sensors that we're not able to provide with an NIST certificate. But pretty much everything else we can provide with that NIST calibration and traceability documentation. And there's an example here on the screen of that process. Moving into some of the more specific configuration questions, starting with room sensors, common question is, what set point value do I need? So the set point is that slide potentiometer that you see on the bottom of the sensor, and it's a separate secondary output distinct from the temperature sensor. So sometimes a lot of people don't realize that it's a second resistive output distinct from the temp sensor. So when we ask a customer what set point they need, they'll say 10K. Well, that might be the 10K thermistor. That's the temperature sensor, but the set point is a different output. So we can help at ACI we can help you choose or determine which one is going to ensure system compatibility with your control system. Every control system out there has a different default, not only for the temperature sensor, but also for the set point. And we can help determine which is best for you. Does ACI offer thermostats? No. All of our products are technically sensors, so they don't offer any control or switching mechanism built into the sensor itself. They're all designed to produce a stable or steady output or a continuous output back to a control system that interprets that output. For lack of better terms, our sensors are dumb. That just means they're just outputting a signal, and another device is used to interpret that signal to determine, when additional heating is needed or when additional cooling is needed, and down that line. Are ACI sensors communicating? And some are. We do offer a full line of BACnet, MSTP, and Modbus communicating devices. But our standard thermistors and RTDs and transmitters, those are not communicating in the similar way that a BACnet or Modbus protocol is. So standard thermistors, they're just outputting a signal. They're not designed or able to do two-way communication or be daisy chained together to allow for multiple sensors off of one power supply. For indoor wall mount sensors, what options do we have for splashdown or washdown applications? And for these applications, we typically recommend using an outdoor air sensor indoors, and that's the sensor that you would see on the right-hand side of your screen. That's available in a number of different enclosures, including NEMA 3R and NEMA 4X housings, and can withstand direct spray and wash down and splash down applications. If you need something that's a little less obstructive or something that's smaller and sleeker in size and form, we recommend using the stainless plate sensor, which you see over on the left-hand side of the screen. And the stainless plates aren't 100% completely watertight, but they do provide a level of protection. They can be washed down or wiped down to provide much more protection than a standard plastic wall mount sensor enclosure. Button sensors are small ways to measure temperature in the space. And the most common question we get on those is, can they be painted over? And yes, on the screen, you see a plastic button sensor, and they can be painted over. We've had people, use drywall mud over top of these. It's going to affect the response time and the responsiveness to temperature changes, and there's no real way to determine how much that paint or drywall mud would affect that. And the other thing we'll note or ask people to pay attention to is, you paint over it and they might be very hard to find. So you may want to put on your drawings where exactly the sensor is, or indicate that otherwise, if the sensor needs to be replaced or serviced, or someone needs to know that location in the future. How do you install these button sensors? And the plastic ones, like you see on the screen here, they're shipped with a drywall anchor, like you see here. And so they're commonly installed through drywall, sheetrock, through ceiling tiles. And the metal button sensors are shipped with a lock nut that screws onto the back of the button to hold it in place. So for similar application. It can be installed through drywall or sheetrock. Sometimes people will install them through a stainless plate, a wall plate or junction box cover, attach the button sensor to that. If you look at the data sheet for our button sensors, you'll notice that not all of our standard thermistors are offered in the button sensor enclosures. And that is because of the physical size limitations of the actual buttons themselves. So it's not all of the sensing elements that we offer can physically fit inside of those buttons. And that's why not all are offered in that specific configuration. Here's an example of the metal button sensors are available in either stainless, like you see here, or brass. And they're shipped with a lock nut that would screw onto the back to hold it tight in place through sheetrock or a stainless plate, like we mentioned. Moving on to the stainless plates, a question we get regularly is, are they offered with some of the common options that are with our standard room sensors like set point, override, and communication jack? And yes, the common options are the override button, as well as a RS-232 communication jack, which you see here. So those are readily available for stainless plate sensors. We do have a very limited number of set point dials. And so please reach out to anybody here. We can give you up-to-date information on the availability of those options. We do offer tamper-proof screws with our stainless plates for applications where you don't want anybody to mess with the sensor. These are an accessory, so they would have to be ordered separately from the stainless plate sensors themselves, but we do have a tamper-proof screw option for the stainless plates. Are there other options available for stainless plates, like color, size of the plates, different materials? And yes, of course, there are. We've done stainless plates in different colors. We've done white, we've done black, we've done them in different materials like aluminum and brass, and we've done different sizes as well to fit over, say, a 2x4 or 2x4 is standard, but we've done them to fit over 4x4 boxes as well. And please reach out anytime. We can give you up-to-date information and pricing on those other options that may be available. Moving on to our duct sensors, the most common question is, what probe length do I need, and where is along those lines, where is the sensing element in the probe? And for all of our probe style sensors for duct and immersion, the sensing element is epoxied into the tip of the probe. And so we recommend for duct sensors, you use a long enough probe so that the tip of that probe is in the middle of the airstream. And we have probes ranging from 1 inch in length up to 48 inches in length to fit into nearly every size duct that you might be able to think of. These probes are made of a solid or one-piece 304 stainless steel probe or tube. And so there's some competitive parts out there that the probe is like a cylinder with a cap that's crimped or glued together. So our probes are not of that style. It's a one-piece 304 stainless steel. As such, the tip of that probe could be submerged in water because it is one piece 304 stainless, but the entire probe is not submersible. So if water gets into the backside of that probe or were to fill that probe, that is likely going to lead to a sensor failure, but the tip of the probes are, watertight. Which of the standard duct housings are plenum rated? If you look at the screen, the three housings that are on the right-hand side of the screen, the black plastic box, the metal galvanized box, as well as the NEMA 3R aluminum bell box are all plenum rated. The only one that is not is the polycarbonate NEMA 4X housing. How long are the wires and what size, and what do the different wire colors represent? So the different the wire lengths, I would refer you to the data sheets. There are some different wire lengths or standard wire lengths for all of the different configurations, and those are called out on the data sheets. For standard duct sensors, the wires are either 14 or 24 inches long, depending on the length of the probe, and that includes that probe length. So for probes 8 inches and shorter, the wire's going to be 14 inches, including the probe. And for 12 inches and longer, they're going to be 24 inches, again, including the probe. They are all 22 gauge is the wire size. And what do the different wire colors represent? That's an internal quality control mechanism. So they represent different sensor elements. So the different thermistors that we use in different RTDs are each going to have different wire colors. So as I mentioned, that's an internal quality control mechanism. And it also is a tool to help us identify devices in the field and determine what they are after they've been shipped. And if the labels have come off, whatever, we can help identify the sensing element by the wire type or wire color that's used. Standard bullet probes are kind of the jack of all trades of temperature sensors. That's a common question is what are the uses? What do you use these for? And the options really are limitless. You can drop them into a thermal well. You can strap it to the outside of a pipe. People will hang them inside of an existing room sensor enclosure. So say there's an existing thermostat on the wall and you're replacing it with a DDC system. You can put the bullet probe inside of that housing and just wire that back to your DDC system. They can be tied to heating and cooling coils. So there's really no limit to the number of options that can be done or where these can be used. What's the difference between the bullet probe sensor and the pipe mount sensor? So on the screen, you see what we call a pipe mount sensor. It is a 1.1 inch brass probe that is crescent shaped. You can't quite see it here in this photo, but the bottom side of that probe is crescent shaped to allow it for direct contact with a pipe. And there's a notch on the back side of the probe that holds a wire tie in place. So the pipe mount sensor is designed specifically for strapping to a pipe, whereas a bullet probe is a 1 inch stainless steel probe that's round, and it can certainly be strapped to a pipe, but there's also a number of other applications that you can use bullet probes for. Moving on to our immersion sensors. This is a common question is what insertion length do I need? And we recommend that the tip of the probe be inserted 1/3 to halfway into the pipe. If you're in between lengths or you're not sure which length to use, we'll generally recommend going shorter rather than longer to minimize obstruction of flow in the pipe. We don't want to encourage turbulence or any obstructions to the water fluid flowing through the pipe. Are thermal wells included with the immersion sensors when you place an order? Yes, our default part numbers include what we call a fabricated or welded thermal well. Those are the ones that you see on the left-hand side of the screen. So that is included in our default part numbers. The immersion sensors can be ordered without a well, or they can be ordered with a machined well, which you see over on the right-hand side of the screen. And that leads to the next question is what's the difference between the machined and the fabricated wells? And I'll go back to this picture to show you that the fabricated wells are made of 2 pieces of stainless steel that are welded together. There's a weld inside of the female thread, whereas the machined wells are cut out of one solid piece of stainless steel. And as mentioned, the fabricated wells are the default or the standard well that it comes with our immersion sensors, and those are included with our standard part numbers. So this is a question that makes me laugh every time I get it. It comes in pretty regularly. And so someone orders a 4-inch immersion sensor, but when they get it, it's 6 inches long. And so we'll get a picture. We made a graphic here, but I've got several dozen of photos just like this in my inbox over the years. And people will say, hey, I ordered a 4-inch sensor, but you sent me a 6-inch probe. You know, can you guys measure? Do y'all know how to do math? What and all that? So I've gotten all of those comments over the years. And so it goes back to how we label and measure immersion sensors. So what we call a 4-inch immersion sensor it's measured from the tip of the well to the base of the threads on the well. So a 4-inch sensor is going to be 4 inches from the base of those threads on the well to the tip of the tip of that well. So this 4-inch sensor will actually use a probe that's a little bit longer due to the length of these threads. So if you order a sensor without a well, so if you order a 4-inch immersion sensor without a well, you're going to get a probe that's about 6 inches long because it has to accommodate the threads of the well. So it happens fairly regularly where someone will pull a sensor out of an existing well, measure it, and say, hey, Brant, send me a 6-inch immersion sensor with no well. We send them a 6-inch sensor that uses an 8-inch probe, and then I get the next day I get an email with a photo like this of the sensor with a tape measure next to it. So it can be confusing, but we always measure or label based on the actual insertion length of that well. And so a 4-inch well, a 4-inch sensor, the probe's going to be slightly longer than that. And if you've ever got questions on that, please reach out. Happy to help. And one of the tricks too that you can do if you get a sensor that's a little too long, you can push the probe back into the box a little bit as well. So that there, you can kind of lean on this box a little bit, and you can push the probe back into the box to accommodate it into a shorter well. Get to that here in the next couple of questions. What are the thread sizes? All of the threads are 1/2 inch. So the external thread or the male thread is a 1/2 inch tapered. And then the internal thread here is 1/2 inch straight. What are the wells made of? All our standard wells are 304 stainless, both the fabricated wells and the machined wells. And we also have 316 stainless wells available by special order. Do we have any hot tap style sensors or fittings or wells? And no, that's, from my understanding, that's a type of well that allows it to be installed without having to drain the system. It's got a valve built into it. And no, we've never seen any of these that are completely leak free. So we don't offer anything like that. Our wells do not have an NSF rating. That's a rating that's commonly used for food service applications. However, I have seen some of our 316 stainless wells be approved in these types of applications, but we do not have a specific NSF rating on any of our thermal wells. Is thermal grease required or recommended when using ACI immersion sensors and wells? No, we don't require it. And when you order new sensors and wells from us, it's really not needed because there's a very snug fit between the sensor and the well. We do recommend using thermal grease if there's a retrofit or you're putting a new sensor into an existing well that it's not a perfectly snug fit. Like if there's any gaps, whether from the well being too big of a diameter. All of our probes are a 1/4 inch diameter. So if you've got a well that takes a 3/8 probe or it's a little too long, we do recommend using the thermal grease to fill that space. For outside air sensors, the common question is, where's the best location for mounting an outside air sensor? And we recommend those be mounted on the north side of a building and or under an eave or anywhere out of direct sunlight. Direct sunlight can cause it to self-heat and give an inaccurate reading. For those applications in which you have to, there's no other location but in direct sunlight, we do offer a sun shield option, which you see on the right-hand side of the screen. That is a large enclosure that radiates the heat away from the sensing element to allow for an accurate reading in direct sunlight. The probe extends up from the bottom into the middle of these plates to keep any direct sunlight or direct heat away from the sensing element. Do we offer sensors for temperatures below -40 C or F? And yes, our standard thermistors are rated down to -40. We do have a low temp option that I believe goes down to -192 degrees C. I can have that in my cheat sheet here. I'm sorry, it's 198 degrees C that our low temp sensors can go down to. And those are RTDs or transmitters. Thermistors are not able to be accurate at that low of temperatures just due to their the nature of the sensing element. We mentioned this briefly before, outdoor air sensors used indoors, and absolutely it's a great option that's low cost and weather tight for indoor applications where they might be wash down, splash down applications. Moving on to averaging sensors, and as I said, I'm coming at you rapid fire with these questions. I'm still keeping my eye on the clock. I don't want to keep you here all afternoon, so in a little while I'll call it quits on the webinar, and we'll have all of the Q&A posted on our website here as well. So for averaging sensors, the most common question is what length do I need of that element? And we recommend using 1 foot of element for every 1 square foot of the duct cross section. So just measure up the cross section, the length and width of the duct, get your cross section square footage, and use 1 foot of averaging sensor per 1 square foot of that cross section. Are the averaging sensors multi-point or continuous? And the answer is both. For thermistors and for 1K nickel RTDs, they're multi-point. So that means that over the length of the element, there will be multiple sensing elements that are wired series parallel to get an average of the multiple sensor readings. All of our platinum RTDs and transmitters are continuous, and that means there's one thin film sensing element that's stretched out across the entire length of that element, whether it be 12, 24, 50 or feet or longer in length. Are mounting accessories included with averaging sensors? Yes, with every averaging sensor, we include wire ties and a wire tie bracket that's adhesive, and it can affix to the side of the duct. Those are included automatically with all averaging sensors, or I should say all copper and flexible averaging sensors. We do offer both copper capillary clips, and the one on the right we call a universal clip that can be used with both averaging sensors or our freestats. And these are available as accessories, available as a separate or separate line item from any averaging, whether it be copper or flexible averaging. Can averaging sensors be used with UV irradiation equipment? Yes and no. The copper averaging can, but the flexible averaging should not be used with UV equipment. Are these elements submersible? So we've had that question. People want to drop the averaging sensor into a tank and get an average of the water temperature in a large tank. And nope, do not do that. These elements are not watertight and should not be submersed in any kind of tank. For low temp freezer glycol bottle sensors, the common question is what's the purpose of that glycol bottle and that glycol solution? And the purpose is to act as a thermal buffer, which in essence slows the response time of the sensor. And so the idea is if you've got a large cooler freezer, you don't want to open that door and have the sensor hit with a rush of room temperature air. Could send the system into alarm. And so the sensor is installed into a glycol bottle, which then acts as a buffer, slows the response time, and allows the system to trend the longer term fluctuations in temperature. It avoids unnecessary cycling of the cooler, the heat or the cooling system, for when it would get a shock of that room temperature air. Is the probe submersible? Yes, like the other probes, and I'll go back to this slide, the tip of the probe is submersible. The entire length of the probe is not. So when installing the probe into the glycol bottle, ensure that just the tip of the probe is into the solution and that the solution, the entire length of the probe is installed into the solution. What's the shelf life of the glycol solution? And I believe that the shelf life for that is let me look at my cheat sheet here. It's 2 years if stored at room temperature and outside of direct UV light or sunlight. What's the purpose of the 3-point glycol bottle that you see on your screen? We see a number of applications, specifically pharmaceutical storage, where redundancies are required. And so this allows for multiple sensors to be installed in the same cooler, same freezer, and allow for multiple redundancies in one area. What's the difference between the low temp sensor or LTS probes and the standard bullet probes? The LTS probes are built out of some different materials. The sensing element is built a little differently to withstand the lower temperatures. And there's also some physical size differences. The LTS probes are 3/16 in diameter and 2 inches long, whereas our standard probes, our standard bullet probes, are a 1/4 inch diameter and 1 inch long. The LTS probes are also 3/16 stainless, whereas our standard bullet probes are 304 stainless. And the LTS probes, the freezer probes, are also IP68 rated, which our standard bullet probes are not. I think I'm going to keep going. We're getting to the end of our slides here, so we only got a couple more minutes. So I'll finish up, and then I'll take any questions that you all have here. So moving on to our TTs, that's our temperature transmitters. Our data sheet shows 2 different types, a TT and a TTM. And so the question is, what's the difference? TTM stands for matched. And so that means that the sensor and the transmitter are built together, and they're built, tested, calibrated together as one unit. And so that allows for the calibration to kind of calibrate out any of the sensor error. And the TTMs are also provided with an NIST calibration certificate by default as well. The TTs, the standard TTs, they do not come with an NIST certificate, and they also, the sensor and the transmitter may not be built together. They might be paired together and then calibrated to the specific temperature span that's required. Do these transmitters require periodic recalibration? That we do not have a standard or recommended calibration interval. There's a number of applications that require recalibration, and we leave that up to the requirements of the specific job or the specific application. We do offer recalibration, recertification services. And so at any time, any of our sensors can be, any of our transmitters, these are 4 to 20, 1 to 5, or 2 to 10 output devices. These can be sent back to us for periodic recalibration or recertification. There is a small fee that's charged for that service, but it can be done at any time. Other outputs besides 4 to 20, yes, 4 to 20 milliamps is the default output for our temperature transmitters. We also have 1 to 5 volt and 2 to 10 volt output options that are available. And stay tuned. Hopefully in the coming months, we'll have some additional options available as well. What's the accuracy or the combined accuracy of the sensor and transmitter? And so it's very difficult to give a one-size-fits-all answer to this question because the different components of the device all have different levels of tolerances. So and the different temperatures in which they're operating can affect the accuracy of the devices, both the sensor and the transmitter. So I would refer you to the data sheet of the specific sensor that you're using where the accuracy is called out there. It's hard to give an overall accuracy due to the variability of the components used as well as the specific applications in which they're being used. Are the RTDs used 2-wire or 3-wire? All of our devices are 2-wire. Our boards, our temperature transmitter boards, can accept a 3-wire RTD input. So you can use our boards with maybe some RTDs that you may already have in the field. Typically on a 3-wire RTD, you're going to have 2 wires that are the same color and 1 wire that's a different color. You would just tie those 2 wires that are like colored together into one side of the terminal block on our transmitter boards. Can the RTDs be ordered separately from the transmitter? Yes, of course. Yeah, they can be packaged together in one unit, or they can be ordered and mounted, installed separately. What are potted transmitters? Yeah, that's something that we've had for the last few years now, and that's essentially a transmitter board that is completely encapsulated in epoxy, in which the leads are tied into the terminal blocks, and they're just flying lead wires coming out. And so that is a great solution for very high humidity or other rugged applications that would require a very rugged and durable transmitter and electronics. Yeah, sometimes these are referred to as ruggedized, or you'll see them as with an R in the part number, or they're sometimes called potted transmitters. So there, I made it through. We got done with all of our Q&A, or all of our FAQs. So now I will open it up to questions. If you have questions, please put them in the chat. I did have a few questions that people had sent to me, to my email, and to me on LinkedIn as we were announcing this webinar here in the last week or two. So I'll answer those as promised. So the first one is, do you offer explosion-proof housings? Yes, we do. We have explosion-proof housings for wall mount, duct mount, and immersion mount. And those are class 1, div 1 rated housings, and they're available in thermistors, RTDs, or transmitters. Transmitter question is, what's the difference between a TT100 and a TT1K? And yeah, I should have mentioned that a minute ago when talking about transmitters. Is on the data sheets, not only do we have TT and TTM, but we have TT100 and TT1K. And the difference is that the TT100 uses a 100 ohm platinum RTD, and the TT1K uses a 1000 ohm platinum RTD. The different RTDs with 100 ohm versus 1000 ohm, they both have the same accuracy. They follow the same curve, just 1 decimal point over. The TT1K is available in a wider range of configurations. For example, averaging, we don't offer 100 ohm RTDs in averaging. And if you were to choose, if you have the ability to choose which, generally recommend the TT1K, the 1000 ohm, just for the reason that you can get a little better resolution because it takes less of a temperature change to move the ohm value, say 1 ohm in either direction. What colors are available for ACI room sensors? That was a good question. We have 2 standard wall or room sensor housings. We have what we call the infinity housing. That's call it our older style, and that's signified by R in the part number. That is a beige housing by default, but it's also available in white and black. Then we have what we call our Aries housing, and that's signified by the R2 in the part number, and that one is white only. What spans are available for temperature transmitters? So for temperature transmitters, we can do a very wide range of spans. There's not a standard or a default temperature span. They're calibrated individually per order, per the customer's request. So the span must be at least 50 degrees F in breadth. So you have to have it, say, 50 to 100 degrees F, and they can be no more than 1000 degrees F in span. So you could go 0 to 1000 degrees F. That's the widest it could go. Pretty much outside of those limitations, you can do whatever span you would choose. For the TTMs that are provided with NIST certificates, the limitations are -45 to +155 degrees C. And those are based on, that limitation is based on the specs of our testing chamber. And then last question I have is, are custom options available? And yes, we do have a number of custom options and things that aren't seen on our website. So if you are looking on our website and there's things that you don't see, please reach out. That doesn't mean we can't do it. We do a number of different wire types and fittings and housings and logos. We can do custom branding for your logos. Question came in on the chat from Kyle. Thanks, Kyle. He says, is there a maximum length a sensor can be run before it starts losing accuracy? Yes, yes and no. Thermistors, one of the advantages of thermistors, I said I wasn't going to go into the advantages and disadvantages, but one of the advantages of thermistors is they typically experience less voltage drop over longer lead runs than do like RTDs. If you have an application where you need to run wire over longer distance, we'd recommend a thermistor. There also is a formula that we have that we can provide you that can calculate that voltage drop if you're using an RTD. Generally, we recommend if it's 20 feet or less, don't typically have to worry about the voltage drop. If it's more than 20 feet, then you'd want to plug that formula into your controller to calculate that voltage drop. So that's what I had for today. Thanks to everyone for joining us. I appreciate the continued business and your questions. And as I mentioned, all of this Q&A is up on our website now at workaci.com/FAQ. And if you've got questions that I didn't get to, or you're watching the archived version at some point in the future, you can reach out to the email address on your screen, or you can reach out to me directly at bk@workaci.com. Thanks for watching, and look forward to talking with you again soon. Have a great day.